In attempts to conserve water, a restaurant adopted a water by request only rule. Test the claim that 30% of patrons do not request water at a 5% level of significance. Use a sample of 480 patrons in which 125 did not request water. So let's start with a null and an alternative hypothesis. The null hypothesis is that the proportion is equal to 0.30 that do not request water. The alternative hypothesis is that the proportion is different from 0.30 that do not request water. So we will test this at a 5% level of significance, and we can use either the traditional or the p-value approaches. So why don't we stick with the p-value approach. But first we have to say that we know that for any proportion problem we have to verify NP and Q are greater than or equal to 5, so that's 480 times 0.3 and 480 times its complement, 0.70, and multiplying each of these out gives us 144 and 336. So that tells us that p hat is normal, and so we're going to test the claim at a 5% level of significance. Alpha is 0.05. So let's compute a p-value, and to do so we'll go with a drawing. P hat is normal. We're assuming that the proportion that don't request water is 0.30. We have a two-tailed test. So what is the proportion that we have in place here? Well, it gives us into the number of people that do not request water. We can make that into a proportion by simply dividing. So p hat is 125 divided by 480, and let's get this to 4 decimals just to be safe, and I get 0.2604. And that's to the left. So the p-value is going to be 2 times the probability, since we have a two-tailed test, that p hat is less than or equal to 0.2604. And just a quick note here, which is, again, we really are using histograms, but because the continuity correction would be 0.5 divided by 480, the continuity correction can be ignored when 0.5 over n is significantly small. So let me just stipulate that. The book actually doesn't mention anything about it, but continuity correction can be ignored when 0.5 over n is significantly small. And this, of course, happens in cases where we're dividing by 480. So we're going to actually ignore the continuity correction in this section, and all of our samples and in the homework will be significantly large. But I just figured I would mention that here. So continuing on our p-value, we're going to translate into z's. We're going to get twice the probability that z is less than or equal to 0.2604 minus the mean, which is 0.30, and divided by the standard deviation, which is square root PQ, which is 0.30, 0.70, over N, 480. So this is twice probability. Z is less than or equal to, and run this into the calculator. 0.2604 minus 0.30 in parentheses divided by parentheses, square root 0.30 times 0.70 divided by 480, close parentheses. And I come up with approximately negative 1.89. So let's look that up on our Z table, and then double it, and we'll have our p-value and can make our conclusion. So negative 1.89 gives us 0.0294. And when we multiply that by 2, come up with 0.0588. And so at a 5% level of significance, since our p-value is greater than alpha, we don't reject. H0. In other words, at the 5% level of significance, there's no reason to reject the claim that 30% of the people do not request water at the hotel.